Hello everyone. Today I'm going to be talking to you about RealM towards speed separation on real mixtures. And this is joint work with Mirko Ravanelli, Samuele Cornell, and François Grandin, and I'm Cem Subakan. I hope you will enjoy the presentation, so let's get started. So let me first talk to you about the motivation behind RealM, right? Why are we doing what we are doing? So essentially, we've seen that over the last couple of years with the proliferation of deep learning based speed separation, the problem has been we have made a lot of progress in the field. Let's say, right? We have reached very impressive performance on synthetic data sets, but the performance on real life speed separation hasn't really reached the performance we get on synthetic datasets. So to demonstrate this, I will play one example from a synthetic dataset and one example from a real life, two examples from a real life dataset, and see if you can hear the differences.
When
The
its
index
initial public
ended with a
offering is
decline of
completed, comma, Ashland
0.35.
is when its initial public offering is completed, comma, Ashland is
The index ended with a decline of 0.35.
See, I left your packet on the desk.
Recording.
Oh, thanks. See, I left your packet on the desk. Oh, thanks.
Hi everyone, welcome to the recording.
But under such circumstances, I doubt that such an arrangement can be made.
endeavoring to put in.
But under such circumstances, I doubt that such an arrangement can be made.
But Sarvajak took it for granted that the Doberino was endeavoring to put in.
So as we can hear, there is a significant difference in quality between this synthetic and real life examples. Summary, our goal in this work is systematically evaluating the speed separation models on real life speech mixtures, right? And our contributions are, we propose a dataset for real life that consists of real life speech mixtures, right? This dataset is crowdsourced, so it's scalable and diverse in acoustic conditions, recording hardware and speakers. And we show that blind SI-SNR estimation is a feasible way to evaluate the real-life speed separation performance. This is important because, if you record a mixture, we don't have the ground truth, right? So we investigate whether just by looking at the separation results, are we able to do something? As humans, we can, right? Like when we listen to a mixture, we are able to say if it's good or not. And, as final important thing to point out is that these observations opens up a scalable methodology for large-scale real-life source separation evaluation, right? All right. So with this, let me talk about the how we deal with the lack of ground truth data that I just mentioned. Right? So in synthetic data, essentially the way the mixtures are created is by simply adding several, in this case two, in this picture two, but it can be more, number of sources, right? These signals are simply added in time domain, and that constitutes a mixture. And then the separator gives some results, and then we just calculate some sort of distance using the result and the ground truth, right? But whereas in real life separation, we don't have the ground truth examples. So what do we do? Like, what do we do with these results? We can listen to them, but you cannot listen to thousands of examples for hours on end. You cannot do that. So basically, we will investigate if we can use a neural network, a machine learning model to be able to estimate this performance, right? So to nail this point home, so let me play you two different mixtures. One will be good and one will be bad.
The ballet
Who was a
began the
born
effect was
outcast
more
of the
than beautiful.
infantile world? Who was a born outcast of the infantile world?
The ballet began the effect was more than beautiful.
But under such circumstances, I doubt that such an arrangement can be made.
endeavoring to put in.
But under such circumstances, I doubt that such an arrangement can be made.
But Sarvajak took it for granted that the Dilgerino was endeavoring to put in.
And, as humans, as I've said, we are able to say that, for the first one was good and the second one was bad, right? So we can do it. Why can't a machine learning model do this for us, right? So basically, we would give the source estimates and the input, meaning the mixture, to the network, and then the network should be able to estimate the performance. So if we come back to the picture that I was telling you before, what we do is essentially just a neural network F would take in the mixture and the estimated sources, and hopefully it will be able to tell us if the separation result is good or bad. All right, so now let me talk a little bit about data collection. How do we collect the real life data, right? So as I mentioned, we do crowdsourcing. So for this, we prepared a website on which people first enter their some basic information about themselves, like their gender, whether or not they're a native speaker, native English speaker, and then we show them series of sentences. They record themselves on the website, and then they submit the recording, and we give them a code, and that code is pasted to Mechanical Turk, and we pay them, right? So this is a scalable way. We are it's easy to collect a diverse set of mixtures, speech mixtures, this way, right? Just to make sure, this is we did this for 2 speakers. So, and therefore we asked the speakers to be in the same room while they speak, right? And we collected 3 hours of speech from 50 unique speakers with various native and non-native accents. Now, let me get back to the details of SASNR estimation. As we were saying, the SASNR estimator basically takes in the mixture X and the source estimate S hat. And this opens up the possibility to create an evaluation framework even if you do not have the ground truth source. But how is this training pipeline, right? So essentially, this training pipeline consists of a pre-trained separator and SASNR calculation afterwards, right? So namely, we put in the mixture X that goes through a pre-trained separator, gives the results S1 hat and S2 hat, and then we calculate the ground truth SASNR values by finding the best permutation over which the ground truth sources are assigned, and this gives us the SNR ground truth SNRs for both source estimates, right? And then the SASNR estimator is trained to minimize the deviation between the estimated SNR, denoted by SNR hat, and the ground truth SNR that we denote by just SNR, right? As I was mentioning earlier also, the SASNR estimator takes in the mixture X and the estimate SK hat, right? K for the kth source estimate. And also I would like to mention that the SASNR estimator, we found that a convolutional neural network in time domain works the best. And the cost function is essentially the sum of deviation of 2 SNR values, right? And we use LibriMix and WHS0 mix to train this SISNR estimator, and we add background noise and reverb on the fly as well. So now let me talk about how we evaluate the performance of this SISNR estimator. So the first thing we do is we evaluate it on synthetic data. Here, I'm showing you plot on evaluation on LibriMix and VAMR, right? LibriMix on left, VAMR on right. In all of the plots, basically we show, like, this is basically a scatter plot of estimated SISNR values and true SISNR values. We see that the results are highly correlated with a Pearson correlation coefficient of 0.8. And also we try the mismatch conditions, where the pre-trained separator that is used in training of the SISNR estimator and the separator that is used in testing is different. Here, the estimator in this figure, the pre-trained separator is SEPformer, but we test with DPRNN and COM1000, and we see that the Pearson correlation coefficient is still 0.8. And we also look at the possibility of using multiple pre-trained separators during training, and we see that when we do that, the performance, the Pearson correlation coefficient is a little bit better. And we do that. But now you're probably wondering, okay, we see that it works on synthetic data, but how well does it work on real data, right? Like the point of the study. So for this, we conducted a user study where we showed 50 random mixtures to 5 users, and we asked the users to give their opinion to us, namely between like bad, poor, fair, good, and excellent, right? And here I'm showing you the results of this user study. So for all of the users separately and all of the users combined as well. So on the x-axis, we see the user opinions going from bad, poor, fair, good to excellent. And on the y-axis, we see the SISNR estimate. The best result would be on the diagonal. And we see that when the aggregate results is pretty much concentrated around the diagonal. So we see that the SNR estimator is fairly correlated with user opinions on real life data. But we also looked at whether with the training epochs of a separator, if we see an increase on the estimated SNR as well, and indeed we do. And we also see that the performance ranking on the synthetic VAMR dataset corresponds to the performance ranking on the real M dataset that is estimated by the trained SISNR estimator as well. All right, and this brings me to my final slide. So we see that with the real-life framework, we can evaluate real-life speech separation data without ground truth, and this enables a scalable and cheap way to collect real-life speech separation data. To collect and evaluate on real-life speech separation data, right? But one important point to note here is that performance on real-life data is significantly worse than synthetic benchmarks. And, this shows in our opinion, this shows the need for the community to shift their attention to a little bit more on evaluating on real mixtures. We hope that the community would start putting efforts on improving performance on real-life speech mixtures. And as next steps, natural things to do would be to collect data for casual talking setups, meeting settings, and scaling up the dataset. And with that, thank you very much. I would like to say thank you very much for listening. And I would like to say that all of the work has been done under the SpeechBrain project umbrella, and all of our code and pre-trained models are available on the SpeechBrain repository and the Hugging Face, our Hugging Face repository. Thank you very much again. Bye now.